My name is Scott Woodall, and the presentation I'm going to give today is Django best practices. So some things that we're going to cover today, and this talk assumes that we have some basic Django knowledge. We're going to cover some best practices that work for Ivy Tech, and this isn't meant to be gospel or the law of the land. It's just what works for us, and I thought I'd share what we have learned over the past 9 or 10 years from using Django. Some things we're going to cover is some code organization. So when we write our applications, how we like to structure some of our code to help keep things organized, and the next developer that comes and works on an application, the code is structured and laid out the same. So when we onboard a developer to a new application, it's already in a structure and a format that they're familiar with based on the other applications that they've worked on. We'll cover some models, forms, views, managers. These are kind of some of the core concepts within Django. After we have an application built, we're going to load it up our local database with some data to see how we can improve things from a performance perspective. We're going to try and cut down on the query counts. So for us, one of the biggest performance improvements we see is when we can reduce our query count, and then the query counts that we do have, improving the response time from those queries. Some Postgres performance tips. And then at the end, we're going to try and see, since Django is a server-side rendered framework primarily, we're going to try and how we can push that envelope as far as we can without converting to a client-side framework like React or Angular or Vue. So who is Ivy Tech Community College? So we are a rather large community college within the state of Indiana. Wikipedia has us ranked 4th for unduplicated headcount. So, and then College Stats has us ranked 2nd. So we have a ton of students who come through our doors throughout a typical year. We have been using Django since 2010. We were formerly a Perl shop that did not leverage any kind of modern framework. It was mostly just inline Perl with some HTML sprinkled in there. And we decided to go a different route in 2010 because we thought there were better solutions out there. So our team over the past several years has written 30 custom applications built for the different constituents of Ivy Tech. So for students, we have here our online general admission application. So our ERP system does come with a solution out of the box that allows students to apply to the college. But it was a dated solution. It was not responsive, so it did not work well on a mobile device. And it was not user-friendly at all. So we took it upon ourselves to rewrite our online admissions application for our students in order to give them a better experience and get them through this process applied to the college a lot faster. We've written applications for our staff. So across the state of Indiana, we have express enrollment centers. And you can think of those as like when you go to the license branch and you need to take a number in order to get in line to be serviced. All these express enrollment centers across the state can help students with various problems or help them in the different scenarios that they need when they come to college, whether that's applying to school, financial aid, all kinds of different things. So we have campuses across the whole state of Indiana, and all of them use that for, or use this particular application to help those students progress through those express enrollment centers. And looks like Monday is the start of the semester, so today was pretty busy. They've serviced a little over 1,700 students today. at the Express Enrollment Centers. We've also assisted with faculty. So we've also have an application called Project Early Success that allows Ivy Tech to determine within the first 2 weeks of the start of the semester if a student within like an 80–85% confidence level will fail that class for that semester. So what our faculty and staff can do after the first 2 weeks is they'll come to this application and they will pull out a select set of students. So if I'm an instructor, I can click on my name and it will show me the students in my classes who are at risk. And then that way they can reach out to them to see if there's anything that the college can do to assist them and see if there's ways to identify why that student might be failing and see if Ivy Tech can't help them out. The web development team at Ivy Tech is a small team. We have 4 developers, 1 UI, 1 UX, and a QA person. And we handle all the custom web development and API integrations with third parties like credit card payment processors, Salesforce CRM, stuff like that. Former CIO that we used to have was good friends with several of the other CIOs within the state of Indiana. And he came up that Ivy Tech has a 700-to-1 student to IT staff ratio. So we're on the high end of that spectrum. And this kind of contrasts Notre Dame is 40-to-1. So we're a small group. We leverage, we try and leverage a lot of tools intelligently. And Django is one of those because it allows us to turn around web applications pretty quickly. So who am I? I'm the director of application development at Ivy Tech. I come from a Unix administration background. I worked at Ivy Tech for 13 years, and I helped start and build out the Ivy Tech development team. So originally Ivy Tech did not have a development team. All the software development projects fell in the Unix group. So I got to do my first software development project when I came here and worked on the Ivy Tech team. And I fell in love with software development. It was my passion. I realized I didn't want to do anything else. So Ivy Tech let me kind of spin out and start up the web development team and grow it what it is today. So kind of how we organize our code. So we have a lot of the standard things that you're probably familiar with, and that'd be models, forms, and views. But we also have some additional ones. So services, we usually stuff I/O related things in there. So that could be email functions. It could be functions that need to make HTTP calls to other various third-party services. It could also be some ORM related calls. So anything that maybe writes something to disk, make a network call, make a call to the database could end up in here. We also have utils. So when we first started development many years ago, utils was generally the file where just anything that you didn't know where it belonged would end up in here. But over the years, generally things that end up in code that end up in utils.py is things that help like format things or just other functions that don't belong really in any of the other items. I lost my mouse here, so 1 second. There we go. So here's an example of one of our services file. So at the bottom here, we have a function that kind of wraps all the other functions in here. So for one of our teams, we need to generate a marketing CSV report. So an example of some services is, so we get the applications for the ad campaign. So we make an ORM call to the database to return all applications relevant here. So that's what this function here does. Create marketing ad campaign CSV. So that's I/O. We're creating a temp file on disk. So get applications, or excuse me, create the marketing ad campaign CSV. So this allows us to write this file to disk. And then send marketing ad campaign email. So this is going to make another I/O call, send out this email. And then this function down here is just kind of a wrapper around all those three other functions defined there. And utils. So what we have here is just a simple time to live function. And so we do cache a lot of various different things. And so an example of code that lives in a utils file for us is just does some date calculations. So if we want to keep something in our cache for X amount of hours, days, seconds, whatever it is, we can pass in some parameters here. And that will show us what those, and then return the number of seconds to cache. So that would be an example of utils. Managers.py, so anytime we have some custom ORM queries that we like to, that we find ourselves writing frequently, this is a good candidate to create a custom Django model manager. And we'll show some examples of that in a little bit. Management commands. So here we have a management command that kind of does, it's an interface into our services file that we just went over. This one here, instead of keeping all of the services logic code inside the management command, we just use the management command as a wrapper around our services. So from the command line, you could run this management command that generates that marketing ad report that's contained in the services file. And then domain logic in its own Python module. So an example of this, we have a third-party system that is not, that we don't have any control over. And we needed a way to communicate with this system. And so this is a library that is able to talk to that system, and it's not related to Django at all. And so we just wrote a Python interface into this application that allows students to upload documents for their student record. And so this one has probably been one of my most proud libraries that the team has written, only because it gets shared across other different teams. And so other groups, other development groups within the hallway have been able to leverage this because we abstracted out this logic into its own thing. And so many applications can leverage it, other teams can leverage it. And so there's nothing Django specific in here. So this has been a really popular one. If you're starting a brand new application, so I would suggest that you save the views.py for last. And the reason being is writing the views in the UI, from what I've seen, takes the most amount of time. And so if you can save writing the views and the HTML last, I think you will improve your performance, the output of which you can develop products. So if you can get the models, the forms, the tasks, the services, if you can get that all up and running first, I think you'll see the benefit. And also getting the data model built correctly is really important. And so when you're first starting out on a brand new application, you're making changes to the model all the time, creating a whole bunch of different migrations. And so if you don't have to worry about views when you're doing that, again, that will help speed up development time. And so because Django gives us an out-of-the-box admin, we can use that to act as our views while we're iterating on all of the models, the forms, and the tasks. So don't hesitate, don't feel bad. Come in here, do all your creating, updating, deleting of all the models as you iterate and you build out your data model, and leverage this before you start building out your UI. And there are a ton of hooks that the Django admin allows you to hook into. So the documentation is, everyone knows, it's pretty comprehensive. It's pretty well, all the features that you need are out there. So if you're needing to, like I know a common pattern when you're writing views is to pass like request user into a form to do something. You're able to do that in the Django admin because of all the hooks that the Django admin lets you tie into. And so you don't need to write that view just yet if you need something like passing in request user. Or another example is here at the bottom here. Let's say that you have a user who's a super user, and you need to return a different form for that user. So the Django admin gives you hooks there too, where you can, hey, is this user a super user? Then we're going to return them this form. If not, then we're just going to go ahead and proceed as normal. Django models. So if you can use Postgres, use Postgres if you can. So from what I've seen, Postgres is the database engine of choice for most Django projects. And if you are able to it, you can get some extra goodies for free, just because the Django core project provides these things to you. So if you are able to use Postgres, you get extra things like for some custom fields on your model. So like an array field. If you wanted to ask a user what their top favorite 3 colors are, it might make more sense to store that data on a model in an array field versus a completely new model and a completely new table with foreign keys. Or like the JSON field. So I know that we have used that to store, if we make a request to a third-party API service, and that data comes back in like an unstructured JSON format, we can stuff the whole response into this JSON field and not have to worry about parsing the individual fields. We have the whole response there for us. And it's not just a long string. Postgres will handle the formatting of the JSON for us. You also get for free, if you leverage Postgres, is some specific indexes. So you can define some indexes on your Django model in order to take advantage some of the performance that these indexes give you. And then at the last here is a full text search. So if you're just starting out on an application and you're not ready to go to the full-blown Elasticsearch scenario, Django and Postgres allows you to leverage these features here, where you can create a pretty decent working full text search just using the tools that are already available to you native in the framework. Always use fields that match your data types. So if you need, let's see. If you don't need floats, use integers. So the documentation has a ton of different field types that you can use for your fields. So like, or another example, if you needed an integer, but you know that it will never be negative, use positive integer field. So be careful and take note when you are defining the fields on your models to make sure that you're leveraging the right data types. This will come in, you'll thank yourself when you chose the right one, took the time to choose the right one, because when you start needing to ask questions of this data and start doing like math, or you start wanting Boolean values, the fact that those data types are already there and defined in the correct way will make the code a lot easier. You won't have to worry about converting things or handling a lot of edge cases there. You generally want to avoid the generic foreign key relation type when you're dealing with models. So what this allows you to do is, on a Django model, you can say that this field is a foreign key into either table A or table B. We have avoided this because it complicated things more than the value that it brought. So when you start making ORM calls with the generic foreign key, then you have to add additional logic inside that ORM in order to get out the correct data. And it just became a headache over time, so we generally tried to avoid that. Never allow char field null equals true. So what this does is it now makes 3 values possible for your character fields. So a null value, an empty string value, and a character field, or the value that the end user submitted to you. And why 3 different values is bad is now you have to account for that edge case of when values are null. Django likes to treat strings that are empty or have no value as just empty strings. So if you see null equals true defined in your models, you might want to take some steps to rectify that, and you'll probably be able to clean up some code elsewhere because you don't have to worry about that edge case. Don't be afraid to put models or methods and properties on your models. So you're going to have to start asking lots of different questions from your data. And so here is a sample model from one of our applications. And you'll see most of the code in here is for various properties and methods that have that aren't any Django defined fields or anything like that. So when we need to ask a question from a visit, so like has notification, ordered services, total time that this visit has been waiting, and then we have some transition methods down here. Don't hesitate to put properties or methods on your models when you want to start asking questions from your data. You don't want this code to end up in views or templates because if some of this code ends up in views or templates, then you can't reuse it anywhere. So if you need to ask a question from a model in this view and the code is written in that view, then when you need to write a second view, you would have to duplicate that code. So don't be afraid to stick stuff on the model. And I guess this kind of demonstrates that point. So here we have total wait time as a property on our model. So we get the visit object, and there it is, visit total wait time, and it gives us here. So because we define this on the model, we can now access this in the template, and we can also access in a view. So a view, a template, and the Python REPL, that same property is available in all three places, and that's what we want. That's what we're looking for. Leverage the relationship between your models. So a common one that I see is, let's say that we have two distinct models. We have a visit model and we have a visit history model. And the visit history model has a foreign key defined on the visit model. So a lot of times I will see someone grab a model and then turn right around, will use the visit history objects filter and filter on the visit itself. Django builds out the ORM stuff for you already, so you are able to leverage the relationships that the ORM builds up for you. So you don't need to import this visit history if you want to know all the history objects for a specific visit. It's already hanging off of the model itself. And you can, one thing that I also like to do is to usually figure out what things are hanging off a model is I will do a print dir on the model object itself, and that will print out every property or method hanging off that model so I can see what's available. So this just helps clean code up. You have fewer imports, and it's already there, and you don't have to worry about filtering it. You'll already get all of the history objects associated with that visit. Django forms. So I guess there's two things if you're going to take away from this talk would be get your data types right, and then all data must be passed through a form, no matter what. If the data is coming from a user, it always needs to be passed through a form. And what we want to avoid are scenarios like this, because this will cause a lot of exceptions and edge cases. So if you're in a view and you get a piece of data right out of request post, and then you turn around and then use that inside of an ORM call, you'll get a lot of value errors, type errors, because people, end users won't always pass in the data that you're expecting. So if you're expecting the ID to be an integer and they type in the letter A, you'll get all kinds of errors or exceptions. Where if this were to be on a form and you passed request post into the form and ran it through form as valid, then this type of error would never happen because we would return back to the user, hey, this form isn't valid, you need to pass in something legitimate. And also forms convert all of the data that users send to us from a browser are strings. And so using forms, Django will convert those to the correct data types. So then we can then start acting on those data types as we'd expect, as far as math or string concatenation. The form handling handles all of that conversion for us, so we don't have to worry about it. Oops, sorry about that. And let's say you need to make an API call to something. It's okay to stick methods on forms as well. So here we have a form, and we've put a method on it. So update payment processor. So, and inside here, we've imported from our services because this is making a network call, and we want to update the payment processor. And all we have to do is pass in clean data, because all of the data that we want to pass in is already hanging off of this form that's already been instantiated. So don't be afraid to put additional methods and properties on forms as well. And then forms, generally they'll become an interface for our application. So we want to be able to call the same code in a view and in a REPL and not be too much different. So if we have a form up here and we have our method that we've defined where we update a payment processor, we want to be able to kind of do the same thing in a view than we would inside of a REPL. So here we instantiate the form. If it's valid, yes, then we update the payment processor. We want to pretty much be able to do the same thing inside the Python REPL as well. So instantiate a form. If the form is valid, make the same call, form update payment processor. So this allows wherever you have a form, pass data in, and the services method is the same. So you can kind of future-proof yourself this way as well. So if for whatever reason the logic inside of here ever needed to change, it would just need to change in one place, and that would be inside this method form here. Model managers. So this is where you want to stuff all of your queries at. So custom Django model managers are good for if you find yourself repeating the same ORM calls over and over again. Keep losing my mouse pointer. Bear with me here. So here is an example of our custom model manager. So we have a query set. So let's say, and we've got a bunch of different things that we found ourselves repeating over and over again. And so we centralized all those ORM calls onto our model manager here. So how many users are waiting, a count of how many users are waiting, get the average wait time for all of the users. And then also with custom model managers, you can also do a select related and a prefetch related on this. So no matter where your ORM calls happen for this specific model, it will go ahead and do all the select related and prefetch related for that ORM. So you don't have to carry this around and copy these select related and prefetch related things if you're usually pulling in these data, these other models, when you need access to visits. So don't be afraid to create a custom model manager and start putting all your ORM queries out there. And same thing, this kind of travels around with the model as well. So we import from our managers, we create a custom objects, and so now we're in our views and visit objects for user. So we want to filter all of the visits just for this specific user. So we've centralized that logic and we just pass in the user who's requesting the data. And then we can do the same thing in a REPL. So we grab a user object, visit objects for user, and it's the same thing. So both places in our views and our REPL, we're getting the same data, same code, and there's nothing extra that we have to do. Django views. So I often see a lot of discussion whether something should be function-based or class-based. It doesn't matter. So use the best one for whatever scenario you're currently dealt with. So if you're brand new to Django, function-based views are usually easier to understand and grasp what's going on as you learn the Django framework. If you have a complicated view, if there's lots of moving parts, you're dealing with multiple models, I found function-based views are generally better because it makes a lot of sense. You can see things flow and make it easier to read and understand. Function-based views go a long way for that. If you're interacting with a single model, just create, update, read, delete. Class-based views have tended to work better for us. Mixing matching is okay. So if you have a function-based view and right underneath it there's a class-based view, don't get too hung up that, not a big deal. Red flag, where refactoring might need to take place. So this is one that I wrote several years ago. This is a view. And if I were to go and refactor this, I would go and refactor this today. I would not write this the same way. So after this form is valid, I would just want to call something on the form itself and have it do a lot of this extra logic. So if I were to try to do all this extra logic in the REPL, I would have to know and type all this out. Whereas if all this logic were on a method on a form, I wouldn't have to do or know anything else. So when you see your views start to include a lot of extra stuff, that might be a red flag that it's time to do some refactoring. And I like to make views small, and it's okay to have a lot of them and just do one thing. So here is another example from one of our applications. So this is a view that is all these views here are working on the same model. All these views here are working on the same model, visit model, and they're doing different things, and they're just doing one and only one thing. So this visit is now researching. We need to check the user in. We need to move this user back to the queue. We need to select this user for assistance. So all these things do one and only one thing, and so when the time comes to maybe in the future we need to add some new functionality to this, maybe this specific view, we know that what's going on here is very small and we're not going to break anything else. We have a high confidence level that we're not going to break anything else because it is just doing one and only one thing. This is probably one of my favorite things, and that's faking data in your local database. And we want to be proactive in uncovering performance issues. So we use Factory Boy for all of our unit tests. And so what this library allows us to do is kind of create set of fake models. So we define some factories, and then in our unit tests, when we need like a model with some fake data, we can just call a factory, and then that factory will give us that model. And you can also build out foreign keys and all kinds of different things and get really complicated if you need to when you build out these factories. And we build these for our unit tests. So here's an example of one of our factories in our unit tests. So we notice we need a user for our visit. So we pull in the user factory, and we can define some default values for all of the other fields on our models. And Factory Boy lets us do some fuzz testing. So we can create random email addresses that increment, or you can create random cell phone numbers that are between these two values here. So once we have all of our factories built out, before we go to production with an app, what we do is we just load up our local development environment with a ton of this junk data. So so from the command line, you can import the factory that you just created. And so for I in range 500,000, you can create 500,000 visits in your database that creates all the foreign keys and all the other entries there for you. And what's what's fun next is then you start navigating around your application. So you loaded up your database with 500,000 rows and all kinds of different tables. So now what you need to do is go start navigating around your application, and you will quickly find out, oh, this select widget has way too many entries in it. It takes 60 seconds to render this page. And so what we're looking to avoid here is, like, a year from now, as people start using your application, the amount of data in your application is going to grow. So the point of this for us is we want to kind of get in front of that and see where we need to think through things a little bit more in our application. So when users do actually hit 500,000 rows in production, we've kind of already addressed those issues. Lost my mouse cursor again here, 1 second. And so what you will find is where indexes are needed, list pages where you need to do server-side pagination, and then select widgets that have too much data. Django Debug Toolbar. So after we've got all our data loaded, what really helps us is the Django Debug Toolbar. And we use this. So after we've got all the data loaded, we will start navigating to our different pages. And Django Debug Toolbar will tell us how many queries it took for this view to render, and if there were any duplicates. And we will address any performance issues before it even goes to production. And we know we're good at least for a year or so once we address all of these things. And we usually like to keep query counts less than 30 and under 100 milliseconds. So following those two rules of thumb have kind of helped us out a lot. And in order to, so when you do see performance problems with, you got 100 queries and you'll see there's like 20 duplicates, you'll be able to make heavy use of select related and prefetch related. So this is from the Django documentation. So we grab an entry from the blog and we access this foreign key. This is going to make 2 database calls. Whereas if we do select related on the blog and we print that out, then that's only going to be 1 database query. So you'll want to start navigating all around your application, look at the Django Debug Toolbar query count, and start reducing those numbers. Quick Postgres performance check. So, if you turn on pgstat statements in Postgres, it will start tracking performance statistics. And what you'll see here is you can run this query. So you can select from pgstat statements and order by total time. And so what this will allow you to do is I've only got it returning 1 row. So this is the most time-intensive query on the CPU. So it's been called 2.2 million times, and it's ate up this much time on the CPU. So what can we do to improve that? So we know what the query is here. So we can take this query and run it through explain analyze. And explain analyze is going to return this query plan for us. And it looks like total runtime of this is 22 milliseconds. So that's not bad for this query, but it's still the most CPU consuming one. So let's see if we can't take and improve that. So if we take that, and there's a tool that you can take a Postgres query plan and paste it into, and it will kind of color code where the performance problems are. So 23 milliseconds is spent in this bitmap heap scan here. And so it looks like filtering on a text and checked in. So let's see if we go back here if we create an index concurrently on this column, and then we run explain analyze again, we see that our runtime is reduced to just under half a millisecond. So before, where our query time, if you take the number of times it was called times the 22 milliseconds, that equates to about almost 14 hours of CPU time. Whereas after we created our index, the number of times this query has been run versus half a milliseconds is 16 minutes CPU time. So every now and then we'll check the Postgres PG stat statements and make sure that we don't have any misbehaving queries, and try and keep those numbers low. If you need something heavier than just the PG stat statements, there's a PG Badger software out there, and that just goes over your Postgres logs and gives you way more detailed information than just the PG stat statements would. So all this work that we've done so far, from what I've seen, it results in happier developers and end users. So better experience for developers because the code is laid out nice, it's fun to work in, all the data types make sense, like you don't want to have to worry about parsing a date from a string and dealing with all that nonsense. We've got fewer bugs because we're using forms. All of the data that gets passed in, it gets validated before we persist it or use it in other parts of our application. And we've got nice performance, which end users like because of all of the proactive stuff that we've been doing instead of reactive. So here is a CPU graph of one of our, so we have 2 application servers for these 30 apps that we have. And this was yesterday, and this is literally our busiest time of the year. And so our CPU peaked around 0.4 or 0.5 CPU load throughout the day. And this is about 30 requests a second, which isn't like Facebook busy, but if you sit there and watch the log, things are scrolling by really fast. So how can we get, if we're moving on to the front end of templates, so I've always been a big fan of trying to get the server-side render stuff, make it feel like a single page application. I've built single page applications and they are complex. They do take a lot of effort to get up and running. So are there things that we can do to make use of the server-side rendered stuff without all the complexity of a single page application? So over the years, there's been different tools and libraries that have done that. It's kind of evolved from PJAX to TurboLinks, Intercooler, and the most recent one I've come across is this framework called Unpoly. And what Unpoly does is, give an example here. Get my slides back. Sorry about this. I don't know why I keep losing my mouse. So an Unpoly example would be you decorate some of your anchor tags with attributes that the framework knows about. So up target wrapper, up restore scroll is true. So what this does, when someone clicks this link, this framework will grab the CSS selector that you've defined here and then populate the page with just those changes. And if you don't want your page to change its scroll position, you can pass it along some other parameters as well, which makes it really nice and smooth transition. You can also do some modals. So if you want to have this link go and grab this page, which is going to be a fully rendered page, and just pull out this CSS selector and put it in a modal, that's what this is going to do here. And then we have the progressive web apps. So this has been gaining a lot of traction lately. So what we have here is a side project of mine. And I just kind of want to demonstrate what the Unpoly and the server-side stuff is. So we click on questions, and you'll notice I scroll down here, and if I want to click on a vote for something, can't vote for that one, let's vote for this one. So you'll notice the page and the network requests over here. We click on this button here, and look, the page doesn't move at all, but this was a completely server-side rendered change. you'll notice this number right here, this point value of 30. Like when I click this, this number changes, these colors changes, and so trying to leverage some of these frameworks will get you really far in making people feel like they have a server-side rendered application when in fact, or excuse me, a single page application when in fact it's all for server-side render. So we can come down here. It's pretty slick. And then for the server side, quick demo of that. With the progressive web app, again, this is the side project I've been working on. And so here, we've got a nice home screen icon. Click on this, pull this up, and again, we can start interacting with this application. And it looks like a native app, which is pretty slick considering that this is completely server-side rendered with Django. And the amount of JavaScript code that I had to write this is about 100 lines. And that doesn't grow, that stays with as I add to the application. And Google Workbox is a library to do the heavy lifting for the progressive web app. Django's been good to Ivy Tech. I can't recall a single time where Django hasn't been able to provide us a solution. Every time that we've needed to, every time we've been given a problem and reach out and do something, Django's been there and had it a lot of times to my surprise. So we've got some multiple database support where we need to connect to our Oracle ERP system. There was a time when we had to generate RSS feeds. Django does that out of the box. Search engine site XML out of the box. Caching out of the box. It's extensible. So big fans of Crispy Forms. Handles form rendering, which is a pain, handles that beautifully, and Django braces. Channel for a little bit, if there's any questions. And we're currently hiring a software engineer position, so if you're interested, link.ivytech.edu/Python. Do you have suggestions or any guidelines when upgrading from Django 1 to 2? Do it incrementally. So upgrade from Django 1.7 to 1.8, put it in production, let it run. Upgrade Django 1.8 to 1.9, put it in production, let it run. So just do it progressively. Don't try and go from Django 1.8 to Django 2.2 and push that all in production out in the same day. You'll probably have a bad day. So just take it progressively, do one incremental release at a time, knock out all of the deprecation warnings that you see when you do upgrade, and that would be the best path I would recommend.